All right. Everybody can hear me okay, I guess. Thank you. Yeah, I'm really excited to have you all here today for the open source after party. So this is only the second time that we've done this. We've done an intermediary event, but generally we've kept it pretty slim so far. I'm really happy to have you all here. Next slide. Awesome. So a little bit about me. I'm a product manager at Datastrato. I'm also a Google WTM ambassador and a CDF ambassador. I also work with the LFAI and data and GenAI Commons and also OPIA. So open source Linux Foundation-y stuff is really my thing. I also organize another group called the Data Engineer Things Bay Area chapter. And I'm also your host for this evening. We also have two other co-organizers. So Jessica, who was here earlier, unfortunately is not able to make it here for the rest of it. She's the founder of another generative AI startup called CodeSwitch. And she has also founded another company called Power previously. Her and I actually met through the very first iteration of this event. So I'm very happy to be able to draw people in like this. And she's also a product executive at Clockwork and has been doing that for almost a decade now. Next slide. So Lindsay, who a lot of you probably met downstairs already and is still helping usher people into the space, is also here. She is a data strategy consultant, previously an executive with iCadre, and she is also a co-founder for the Women Who Do Data Club, and she's a venture scout. So if you have any cool startup ideas, make sure that she kind of gets the scoop on that and is our other host, and she'll be joining us in a little bit. So a little bit about our community here and kind of what we've aimed to do. Really, it's a collaborative meetup. We try not to have too many preferences in terms of the technologies, but generally the open source party features some sort of open source speaker and community of some sort. And so generally we want people to really have these high level intermediate to advanced talks where they can really chew and have some sort of technology that they feel is really exciting. So some other upcoming events that are affiliated with us or by friends of ours. Data engineering for AI specifically is still kind of this new niche place, but I really love data engineering, so I want to plug whatever events are around. So one of them is an upcoming first ever iceberg meetup that's happening in San Mateo by a previous speaker who used to be here, Yufei. And that's going to be hosted at Snowflake San Mateo. The third, I think it's actually the fourth AI Alliance meetup. So if you have any questions about that, please do reach out to Chris, who's here. And that's going to also be taking place at GitHub pretty shortly. It's going to be happening on September 9th. Small Data San Francisco, which I'm sure you'll hear Ryan talk about a little bit later, is the first ever sort of DuckDB small data conference that's going to be happening. It's a one-day training, and that's going to be happening at 40 O'Farrell Street. We also have the Low-Key Data Happy Hour. This is going to be, I believe, the third ever San Francisco Low-Key Data Happy Hour. If you don't know Low-Key, there's one in every single major city, and it's just a bunch of data engineers talking data engineering in a bar, which is really fun. And then we also have an upcoming collaboration as part of SF's Tech Week. So we're going to be co-hosting that along with Unstructured Meetup, and that's going to be happening in October. Our speakers tonight are really exciting, and I'm very happy to introduce them today. So our first speaker that we're going to be having is James Wan. So James is the VP of Engineering at Zilliz. So anything that you have in terms of questions for Milvus, please ask him and get into the nitty-gritty details, because he's one of the few people that could probably regurgitate those details for you. He has also worked on some gigantic data systems. So he used to be a senior staff engineer at Alibaba, as well as Headvid, and he also got his start here in California at Oracle. So he's been in and out of the Bay Area, I feel, based on what I saw on his LinkedIn. And so if you have any other questions around distributed data, please do let him know, pick his brain. We also have Jinping Du, who is going to be speaking with us today. He is the founder and CEO of Datastrato. And he was also, for basically like a decade, a Hadoop committer in PMC. So open source, this is a big guy to go to. And he was also the former chairperson of LFAI and Data and has held many leadership roles at large companies, open source companies, by the way, such as Cloudera, Hortonworks, etc. So thank you for speaking with us. We also have Ryan Boyd, who's going to be speaking with us later today. And he is the co-founder of Motherduck. I didn't know this until going through his background, but he has been the head of DevRel at like every single major company that has ever existed, apparently. So he has headed DevRel at Databricks, at Neo4j, and at Google GCP, which is crazy to think about. He's an amazing person. He is also very much within the startup world. He is an advisor to many startups and is also a partner at Hypergrowth. And also, you could be speaking here. If you like the idea of your little head in a circle with a blurb and me excitedly talking about you, you can submit to speak and we can have a conversation and we can do this whole thing, but with you there instead of these guys. Although these guys are pretty cool. Next slide. Also, a thank you to our sponsor, Datastrato. So anybody with the Datastrato logo that you'll see around, you can ask us and we'll give you a free t-shirt. But it's because of them that we got the good pizza instead of the bad pizza. So please do give them a thank you for them. Next slide. If you're interested in speaking, this is a QR code that goes to a form, and you can fill out some of your details there. You can also find me on LinkedIn. It's just Lisa N. Cow, or you can search the Data for AI meetups on the Luma, and you can just message me directly. We're pretty available, so you're welcome to just talk to us whenever you want to. Next slide. So this is only the third event that we've done, but every single time we do one of these events, we actually have a joke at the end of my portion. So if anybody can answer this, or at least come close, we'll give you a t-shirt. Where did you store your dad jokes? Does anybody have any guesses? Ooh, can you repeat that? Your data store? Your daddy's store. This guy gets a t-shirt. Jerry, if you want to grab a t-shirt from that bag actually and pass it to him. Yeah, just that gentleman back there. Awesome. Yeah, your database. So that was very close. That was very close. Okay. Because I really like you all, I'm going to have a second joke. If you want to go to the next slide. Okay. Now that you guys know the deal, okay. Can you describe the perfect date? Who wants to take a guess? Yeah? Hey, first of all, we go on the same Reddit threads. Can you give him a t-shirt as well? The gentleman in the green? Yeah, that deserves a clap. Why? Did you look at my laptop before?
I just have to deal with that all day.
Okay. But yeah, I'm a little bit in shock. Next slide. Yeah, thank you for coming. Keep coming if you like jokes. And if you have jokes, let me know. You might get a free t-shirt because you're the one who gave it to us. So our next speaker is going to be James, if you want to come up here.
So, hi everyone. So, quick introduction about myself. So, I'm James. I work for VectorDB companies. I work for Zilliz. I worked on open source models for a couple of years. Before that, I was a database guy. So, hopefully, it's actually interesting to join a meetup like with both data and AI. So, because I have a lot of interest on both sides. So, feel free to talk to me after the session. And if you get any questions, yeah, I like to discuss. So first question is that anyone know what is RAG, or anyone don't know what is RAG? No? Yeah. What about anyone build a RAG system in production? Could you just raise your hand? Anyone? Couple of them. Okay. We all know large language model is cool, right? It's great. It has a lot of use cases, but you still have to battle with hallucinations, right? So the way we going to handle how a lot of hallucinations is we are going to offer some truth. That is what is RAG, and that is how we build with retrievers, right? So I think today's topic is going to be covered about some of the RAG basics, and also some of the advanced retriever techniques. So how can help you to build a real world RAG use cases, and the final step is how you can build RAG together with VectorDB mills. Okay. First, let's go back to what is a RAG, right? Hopefully, everybody has some concept about RAG, but it's actually consists of 3 different parts. First of all, you have to retrieval, because RAG large language model don't have enough information. So the overall goal for RAG is just using some kind of retrieval system. You can use a VectorDB, you can use a search to get most relevant documents and chunks. And after that, you do augmented. Basically, you use a lot of prompt to give them your insights, to do some process, to do some like chain of thoughts, try to make it a process and generate a prompt and throw it into large language models. So the last step is definitely to do generation. So the large language model help you to do a lot of summary, help you to do generate insight without like need to check every website or every information you have. Right? So that is something we have. So it's like a very general React pipelines. So it's actually have two passes. On the underneath one is how we do offline embedding generation and put into a vector DB. So you may have a lot of knowledge base. It's probably not going to be only text. It could be a PDF, could be an image. I'll actually show a demo about how we can do RAG on top of images, multimodality data. But once you use the embedding model, generate all the information into a vector, then user can ask questions, right? We can also do agentic style, but whatever. So the first step is user ask questions, and find similarity chunks. After that, we prepare for some prompt. It kind of like based on your business, right? You're probably going to add some insights. Then you throw everything to a large language model, right? Today we're not going to talk about how we do generate. I know everybody has its own perfect large language models. For myself, I'm definitely a Cloudy guy, but yeah, I don't do recommendations. Yeah, but after that, you get reliable answers, right? The key step is you need to find useful information before you do generation. Otherwise, there'll be a lot of hallucination because of lack of information. Okay. Yeah, so today we're more focused on the retrieval part, right? Before you do retrieval, you definitely need to do a lot of data preparation. You need to think about how you clean your data, how to process it, how to chunking it. But we are definitely not on any of this part. We are not talking about how we store data in vector DB and how to retrieve very efficiently, but we talk about a lot of tricks that help you to retrieve data better. Okay. So before we talk about what kind of retrieval techniques you can use, I think we first need to talk about how to evaluate, right? So I think there are like three major different things you need to think about. First thing is accuracy, because retrieve is definitely not 100% accurate, right? Any of the search system is more like a similarity search, right? So you need to find a way to improve accuracy to find the correct data. That is the first concern. Second thing is that you need to worry about performance, right? Because you're trying to build online systems. Query per second could be very, very important. Latency could be very important as well. Larger models, you will have several hundred millisecond latency. We definitely don't want the retrieval system to have much higher latency than a large language model. Third thing is about cost, right? We don't want to like store everything in main memory, even in GPUs. Think of you have like million level documents, or you have a lot of like users. You definitely don't want to store everything, right? And there are definitely a lot of other things to think about, right? Scalability, the answer diversity. Sometimes when you're trying to build a recommendation system, I think diversity can be very important. You don't definitely only want to return the most relevant data. Functionality is going to be very important to have like different choice when you want to fine control your data, right? Security is going to be very important. Okay. So how to build a good retrieval system in a RAG, right? I think the first important thing is that you need to build a quality evaluation cycle, right? You need to have all those tricks. You need to have your evaluation data set, and you need to collect feedbacks, right? That is always the important thing to build like any of the GenAI applications, because large models is not 100% accurate, and retrieval is not 100% like accurate as well. So you need to have a way to evaluate it. Okay. So quick recap, right? What is a very general RAG system looks like, right? So you have all the documents, you chunking it, put it into chunks, using embeddings to put into a vector store. And when you have online queries, you're embedding the query as well. You do a similarity search. You find most top key relevant chunks, and you send those chunks together with all the prompt to the large language models for generation, right? That is a very naive solution. Okay. But what's a problem for this naive or vanilla retrievals, right? So I thought three most important things. One is you lose a lot of context while you're doing chunking, right? For example, I have a friend. I go to Paris with my friends. Her name is probably Lisa. Yeah. And then the question is, where does Lisa go, right? So we know that she goes with me. We know that I goes to Paris, but they are actually in different chunks, right? So large models don't have the logic to combine both chunks while we are doing searching, right? So actually context is actually lost while you do chunking, right? Second is you lost a lot of details because it's not like the using a database, right? You do exact match. You're trying to like generate embeddings with a large chunk, and the longer the chunk, then you lose more details, right? We need to find a way to get all those details. It's like finding needle in the haystack, right? Yeah. And third thing is you lost your intentions because when you try to build all kinds of index, you probably don't know what user's query was going to be, right? It's just some random guess. Then what could happen is all the index you build is not going to be work for what user query for, right? So that's a three major issue we try to handle while we build retrievers. Okay. So how do we do that, right? So first technology we want to introduce is actually late chunking. So instead of chunking all the long document and put into embedding models and search, what we do is we actually using long context windows embedding models. So we put the long document into the embedding model. Instead of generating one embedding, we actually generate token embeddings, and we try to chunk only the token embeddings and merge into multiple embeddings. Why this would work? First of all, we can use long context like embedding models, right, to generate one embedding. But since the context is really long and you lose a lot of details, right? Because for example, if you have 10K windows and you try to we're just using okay. So if you have a 10K window and you try to generate an embedding with 768 dimensions, definitely something lost, right? So that's why we need this token embeddings. Those are like very detailed information. If you guys are familiar with what transformer is actually doing, it just generate all those token embeddings, try to send into transformers, get token embeddings with context, and then we do chunking, right? So this chunk, but how do compare with naive chunkings, right? Because naive chunkings, you already do chunks, you lose all the context, but late chunking, you actually have those contexts in these token embeddings, right? So if you see the evaluated result on the right, you see that with longer context, you actually see great improvement on recalls, right? So the longer the document, you see actually late chunking works better, right? But definitely, I think there's a prerequisite that you need this long context embedding models before you do this late chunking. Okay. Second thing is you can build a hierarchy index. So right now we lose a lot of context information, right? So what we can do is we can do a lot of summary on all those small chunks and embedding all those summaries as well, right? So when search happens, you can search on both summaries, you can search on details, and you can find top key results and merge them, right? So in that way, if you ask for a lot of general questions, you can find those answers from summary embeddings. Okay. So third thing we're talking about is actually graph embeddings. So I don't know if any of you guys know GraphRag. So basically what they do is they actually use large language models to generate all the entities, all the relations in a document. So for example, if I know I was currently in San Francisco and I have a couple of friends works here. So where are your friends located? Maybe the guess is just San Francisco, right? So we try to build relationships. It's very similar to a graph database. Some of the guys just use graph database to do that, but there is actually an easy way just embedding all the relationships and all the entities into your vector DB, and you can still search for the relations, right? That can help you to improve some of the logic, especially on some two spots, 3-stop like data set, right? We actually have the comparison between our graph embedding solution with some graph regs. So they use some graph database like Neo4j to jump between all the data, try to find the relations. I'll say that with simple like relation embeddings, you can still get a very good, like impressive performance, right? But I also listed like 2 different graph reg implementations. So if you're interested, you can look at it. Okay, so that is how we handle context, right? The next topic is how we're going to handle details, right? Definitely one of the things we're going to use smaller chunking size. So each of the embeddings have more details, right? But I mean, that is the trade-off between how many contexts you want to have and how many details you want to have, right? So the way I want to introduce actually sparse embedding. So it's very similar to traditional BM25, so it's keyword search. So we actually use BERT to generate a sparse embedding, and each embedding actually shows the chance that this token is going to be very important in one corpus, right? If I have queries, for example, for the sentence, Mills is a vector database built for scalable similarity search. We know that database is going to be very, very important. Vector is going to be very, very important. So if you're asking for any question using these keywords, vector or database, then you're probably going to match this sentence, right? So compared to dense embeddings, it's actually more easier to explain because we already know for each of the dimensions what token it shows. It's keyword focused. It don't focus on any of the context, but it still have a lot of knowledge from BERT, right? So it's still much better compared to BM25. Yeah. So on the right side, we actually have the best model right now for dense sparse embeddings called Split, and you will see that if you compare the recalls or compare the NDCG values, it's actually much faster or much better than BM25. Okay, and the best part for that is you can use both dense and sparse embeddings. You can use graph embeddings. You can use everything to retrieve for your top K, and then you use a re-ranker to re-rank to get a final top K. So re-ranker is nothing but a BERT or some kind of language models. You can even use GPT-4 to do your re-rankers. The way is that they try to evaluate the relevance between query and all the document we already retrieved and doing a re-rank, right? So it actually works pretty good, but it's expensive. So you cannot apply on all of your documents. You can only apply on certain documents you already selected. So I think last trick for that is using filters. So you can have a lot of tags, right? Sometimes you can predict what kind of questions user are going to ask, right? Sometimes for image, you probably going to give them a lot of tags about what it is, about the weather, whatever. But then you have fine-grained controls, right? You can have filtering on it that is like 100% accurate. Okay. So now we have all those details, right? What's the next? The next is about user intentions, right? One of the common way to do that is hypothetical questions. So I got those documents. I send those documents to large language models, ask them what kind of questions users are going to ask about those documents, right? They'll give me a lot of hypothetical questions, and I'm embedding those questions as well. So when real query happens, we just compare similarity between queries and hypothetical questions. That gave us a better result. And you can do it vice versa, right? You can generate answers for those queries using large language models, and you can use these answers to find documents. Because sometimes query and documents are not really similar, but answer and answer are usually very similar. So if you generate something, even the answer is wrong, but it's probably going to contain some of the keywords or some of the important information, and then use this like hallucination to search for real data is actually improve the performance. Actually, OpenAI use the same trick here to improve their ChatGPT. Okay. The other way is just you're going to split all the queries into multiple tasks, right? For example, you ask a question, what is the difference between features of Mills and Zilliz cloud? I think you probably need to split into multiple queries. First is what is a feature for Mills, and then what is a feature for Zilliz cloud, and then after you do that, then you can get all those facts and send to LLM to let them to do the diff, right? And the last thing is always to put everything together. We call it agentic style RAG. So what we do is you can use a lot of tools. You can use retrieval for sure. You can use a lot of like way to hacking your prompt. You can use chain of thoughts. You can use tree of thoughts. It's actually iterates through, so it can help you to solve a lot of like difficult, complex questions. So those are the tricks we play on a RAG system. So the question is, how does the VectorDB can help you, right? So before I step into this part, I gave a quick introduction about Zilliz. We actually open source vector database under Linux Foundation AI and data. Yeah, we store that embeddings, we index embedding, help user to manage massive number of embeddings. We are actually the most popular vector DBs on GitHub, and yeah, we be adopted by like thousands of users, right? Okay. There are a couple of features we can help developers. I think first thing is to build once running everywhere. So we have a very light version that can be running on your laptop. This is just a pipe install thing. So it can help you to build something from scratch. Then you can move to your local Docker, move to your Kubernetes to run everything in your production environment. If you want to scale, use Kubernetes, we can scale pretty good. And then once it's already goes into production, you probably need some managed service, then you can think about using our Zilliz cloud. Okay. And it also has a lot of highlighted features just built for RAG, right? For example, we have dynamic schemas. You know, sometimes the data is just dirty. You cannot put into a fixed schema. Right now we support JSON, we support a lot of map, set data structures. So all the meta information can be stored in a vector DB. We support different kind of vectors, like binary vectors, sparse vectors, traditional dense embeddings. We also have different type of index on top of it. We can also support to store all the tags if you want to do filterings. If you want to play a lot of traditional tricks like Elasticsearch, right? We have all those features. We support head research. We support ranking. We also have like a lot of support to build a multi-tenancy applications. You have like millions of users. Some of the users we want isolation on every user's data. We have a lot of RBAC support. We have multi-tenancy support that helps you to isolate all the users' data, right? We have a lot of ways to help you to reduce the cost. We have disk space index, so you don't need to put everything in main memory. I think that is actually a major challenge for a lot of real-world production RAG systems. We also leverage tiered storage, so we can store some of the data on S3. So if it's really cold, then you don't really need to pay for all those cold data, right? Okay. We also pretty good on performance and cost, right? So I think three things really important for building rapid like make vector DB fast. One is what kind of algorithm you're using. Second is what kind of computation you're using. Third is how you handle the data, right? So on the algorithm side, we have a lot of quantization solutions. We have different kind of index types. Yeah, we support very high performance filterings, and we also leverage a lot of like hardware details. We use SIMDs. We work with NVIDIA on the GPU indexing, help you to improve the performance. Yeah, and last thing is about your data, right? Sometimes you have hot code data. Sometimes you have very large amount of data, and you want to sharding it in a smart way. That is all we handle. So while you are building RAG applications, you don't really need to worry about all the infras, but you can focus on play those tricks and evaluate what can help you to improve the quality. Okay, and yeah, and of course we work with a lot of AI stacks. You might already know about LangChain, semantic kernel, Llama Index. We have integration with all of them. We also work very closely for all the embedding models and large language models, so it can help you easily to build this GenAI stack. Okay. So one last thing is you should start from building your own RAG system. So we actually have a couple of demos. As long as you know Python, you can run it. It's not going to be like huge demos. We have one with chat with your open source software. We have like hundreds of open source projects, so you can ask any questions. We got data from GitHub, from their Slack channel, from their document. So it helps you to learn any of the technology you're interested. Second demo is a multimodality image search, right? So, for example, I can give a red car and ask, can I get a same car but in the blue color? Then you can see you get all those search results, right? With all those search results, you can send it to like some other like image edit to help you to like do regeneration. It help you to control what kind of things you want to build, because sometimes it's gonna be very, very hard when you're doing image generation. It's gonna be very hard to control, right? With this search and reg systems, it gives the image generation model a lot of sense about what things you want to generate, right? And last thing is we actually have a quick demo, so you can run your own reg system in like 10 minutes. So feel free to try it and give us feedbacks on that. All right, I think that's pretty much for my part. Yeah, thanks.
Hi everyone. I'm talking about Grapheno, the next generation open data catalog for AI. My name is Junping Du. We can short for JP. Sorry. This is a little bit about me. I'm CEO and co-founder of Datastrato. I'm long-term open source developer contributors since maybe 15 years ago. So working on a lot of data projects such as Hadoop, Ozone, Unicom. I also RFA and Data Foundation board member. I used to be the chairperson. I previously worked in the VMware, Hortonworks, Cloudera, extra companies that focus on the data area. A little bit about the company Datastrato. So we're the world's first truly open federated metadata lake to unify the data and analytics and AI. I try to make the data to be useful by different engines and different AI training workloads, and we're providing the next generation data and AI fabric. Let's start, before we go through the details of how Grapheno works. We'll start with some two important trends we observed recently. So first is scaling law really matters for data. So we have heard a lot about scaling law, right? It works for a large language model. That's why instead of training a lot of small models, we have the large language model, a generic large language model to try to solving a lot of problems. And also we see the scaling laws is powerful in the social network, right? It's we can see the linking, the Facebook, definitely it works rather than it's a small piece of network. And also it works in the cloud computing as a computing areas, because we see the cloud computing definitely works because it's more efficient and running more effective. About the data is also the same. Instead of to have a fragmented data, if we can get the data together in some way, then we'll make the data more valuable and more consumable by the business. And another trend is about the Tesla, the data in Tesla time for data. So instead of the previously on the data as a data platform, we're run for, or we're try to running faster and faster. We're running TBCDS 99 queries. In each query we'll do some optimization with to try to make the engine run faster and faster, right? But now we are seeing with large language model and or AI technology, we want to be the data platform more intelligent. So that is we call data intelligent time. Just like the auto industry, the previously we want you want a Tesla, or you want a Ferrari or Lamborghini, but now you need something like Waymo, something like Tesla to be autopilots. I think this is a good time. But there's many challenges. So data silo problem is not a new problem. For many years ago, we started to unsilo the data, right? Before in 1980s, we have many databases, but we're lacking of single source of truth. So we have data warehouse to try to gathering data into in the same pool of data, so that we have a data warehouse. I think the same story will happen in the 2010 because of Hadoop technology and also some object store technology in the cloud, then we can store the everything structured data together in the cloud or somewhere, or your Hadoop cluster, HDFS cluster, so that it can be handled by different engines. And also for the next decades is we have the lakehouse, because previously we only solved the problem of we can store the data together, but we cannot handle them together. We need some architecture like a Lambda, Kappa, some computing engines handle for how to ingestion the data, but the other engines try to reading or query over the data. So that is why we need a lakehouse. Moving forward, we do see a lot of new data silos are created. So one of the silos is because of cloud, the multi-cloud, the hybrid cloud. It silos the data in the physical level, and also there are some region silos, such as if you have data as an international company, if you have data in the US, you have data in the European and Asia. Every region they have some regulations to make you to have to be stored locally, and it's not too easy to put every data into the same place. And also there's some other problem for the data silo problem, that is such as the different organizations, they own the different data, and previously it's okay because this kind of silo data is served for your own business or some business group. But now more and more companies find if they want to move forward, they have to leverage data from different departments, different business, try to combine together, especially for large language model, right? For large language model, you have to be more knowledgeable about your data, no matter you business A or business B or business C. So you have to know more about your business instead of siloed a business insights. And more than the silo, there's more challenges rather than just accessing your data, right? Not only the accessing problem or query problem or training problem, it's also the data need to be good care of, such as you will take care of the metadata, you take care of the how to discover your data across different departments, different usage, and also you need to be careful on the data classification, because some sensitive data, how to handle it, and some data is accessed more often or frequently than the others. So you need a different cache policy or store policies, and also for the data lifecycle management will be also a hard problem if your engine different data engines handle themselves. That's why we need a unified data catalog. That means this catalog can make all your compute engines can work with different data sources, and also you can do the data governance and the more things on the data, just as I mentioned. But existing solutions are not very open to scale. If you look at the cloud vendors such as Amazon and Microsoft, they do recently launch some product support these scenarios, but only limit into the ecosystem of one cloud. And also Databricks and Snowflake, they have this year they have done the new unique catalog or Polaris. I would mention it, but they definitely have some limitations. I will mention more details later about the details. So what we do is we go walk through these challenges with a growing community. So basically, we think the next generation data catalog is a core in the new open data architecture, because now we have a standard open data format, and then also we have some open source data engines. I mean, no matter it's open source or not, but we have some standard engines can query this kind of data format. But we're lacking of the standard open standard here in the middle of the core as a metadata. So that's why the Graphene comes with we try to building a metadata lake where you can work with your Hive meta store and some engines building the catalog, and also can work with your streaming system such as Kafka, scheme registry, and it can also work with your unstructured data and your models. So basically, with this centralized metadata lake, you can have a big picture of your whole data, and it can achieve the single source of truth, no matter your data is in different cloud or different database systems or data lakes, and do the data governance together with just like a single sign-on to leverage to make it more easy to access. So here's a little bit about the architecture when you deploy in the multi-cloud scenarios. So basically, in each cloud, you can have a Graphtino serve as a metadata system, but they can connect each other. So there's no single point of failure, and every access point can access the data for the other cloud. And we're providing the access control on top of that, and the data lineage optimization and auditing on top of that as a data governance across different data lakes or data warehousing or even unstructured data. So the key feature provided by the Graphtino, including the single source truth and AI and data catalog, and also the security in one place. So this is a little bit architecture map about the Graphtino. So basically, we have a centralized the core object model that can abstracting from your table data and the non-table data, such as file set, data set, or your model, your topics. It can be abstracted with the virtual catalog, and this kind of catalog is managed together within a single metadata lake. No matter it's in different engines or in different data lakes, we can manage it together. And providing on top of that, we can provide a unified, REST catalog, and also the JDBC catalog can be consumed by different engines, no matter it's data engines or AI engines. And on top of that, you can do the unified processing and unified governance. And on the layer, we have different connections, connectors to connect to different data sources. Some of the data sources can cross, different cloud. We have some technology like operators push down to make sure your computing, if your join tables cross a different cloud, it definitely can accelerating the query process instead of querying everything from one cloud. But instead of we're using the operator push down to optimize this and getting the data as less as possible. And in the same time, we can process the tabular and non-tabular data with the Graphtino together. So for data analytics, if you are familiar with the tabular data, we are providing a unified table API. So in this API, you know what kind of table, what kind of columns, what kind of partition and index there. And also for non-table, such as if you are a data scientist or you are an engineer, you're familiar with the PyTorch array or TensorFlow, we definitely abstracting a fair set API for you, which has some properties, additional properties as a storage locations where you can find your data set and managing it. There's some scenarios such as we build the metadata lake via the Graphtino. This is the main scenarios here for now. If you have multiple data warehouse or multiple data lakes, or even in a different cloud, so we can manage it together with a single metadata layer on top of that. Instead of comparing with the traditional data governance platforms such as Data Hub, such as Open Metadata, this centralized metadata system is actually consumed by the engines, real-time engines. It can be consumed by the Trino, Spark, Flink, or PyTorch, and TensorFlow. And on top of that, we're providing a data discovery, some metrics, and observability, and managing our data pipeline, the data lineage on top of that. So the definition of the metadata lake here is, it providing an open API and an interface, and also providing a single source of truth for all your metadata, and it can be powered by a knowledge graph so that you can store all your metadata in the knowledge graph to have more lineage. And it can be used by, just I mentioned, it doesn't used by people only to do the governance, right? But also can be consumed by the data engines to be, real-time query or real-time training workloads. And it can also be used in the Lakehouse Federation. So it providing a solution for multi-cloud, multi-engines with multiple, data formats. Not only the traditional Hive or Iceberg or Hoodie, right, where we can support, all kinds of data formats in the same time, and we can leverage different query engines and AI engines to make sure your data fabric is end-to-end connected to each other and running very efficient to break down the more silos. In addition, with Graphene, we can make the data and AI team to work more seamlessly. Like previously, we can see a lot of fragment, stack between the AI team and the data team, right? In the data team, sometimes how to using your ETL pipeline ad hoc query, something tools like this. But for the AI team, you're using something different, like a feature store. You're training the model. We handle with unstructured data. But with the Graphene, you can know, for both data engineer and AI engineer, they can, share the opinion each other. And instead of do the data preparation as a black box for AI team, right? Now it's more transparent. You can see how this unstructured data is becoming structured or can be leveraged in training or the inference. Right? You can see all the history here. And at the same time, for data team, it can also track, how this AI models training workloads, working on this kind of data, because we provide a centralized access control, and you can tracking this kind of metrics. So with this kind of tracking matrix, you can have a better policies, ideas, when to move these kind of data sets to be something like a warm or cold storage, or when to move to the hot storage, or when to a better fine-grained lifecycle management on your data. That's in some cases of our user and customers, they really providing the values for cost-effective. And also, it can union structure and unstructured data across the different cloud. In current situation, a lot of companies they deploy their data in the hybrid cloud, right? Especially for machine learning workloads. So in their private cloud, they have a limited resource on GPUs, right? And they have the a GPU in the cloud it looks like unlimited. So when they do the job like training, they will always do something in the private cloud to train first. But if the private cloud is running full, they have to shifting some of the data to public cloud for training. So there will be a problem if there's no managing cross data management across different cloud to know how CPU cloud and work with the GPU cloud. That would be a problem. So with Graphene, we can solving the problem more elegant because we are providing all this kind of management together. You can just set up the catalog, a schema table, and a file set. You can using this kind of simple concept to managing this kind of data set and table, and that can be point to any places, not only the hybrid cloud, maybe the public cloud. You can, with this, the application level, it can be transparent to, whatever the physical location, the training job is running. Another scenario is about you can build a generic data agent with Graphene. So sometimes you want to, just like you want to building a rack system, right? You want query your data with natural language, and this is kind of you asking your data platform, about maybe a complicated questions. Not only you can what stored in our vector store, right? But some of the insights is generated from your data lakes. So there may be the hybrid query, such as you want know, let's say, within your company, what is your top sales recently behavior, such as if you are CXO, right? If you're a CEO, you want to know, okay, how the HR department take care of the top sales. If you ask us this question, you will go through your sales department's as a table, right, to getting who are the top sales, and then maybe on the layer you go to a vector store building by the HR department. So how this they have some inspiring behaviors recently or history about what they do. So this is a kind of combination of query on the tables and search on the vector store. This kind of hybrid should be managed by a metadata center. So in our case, Gravitino can handle this well. So we just has this example. It's just like the link said. This is it's an open sourced notebook to handle this case. So to showcase how we work with the large language model frameworks such as Llama Index to providing this kind of capabilities. There's another work we are in progress to potentially do is to improve the current data intelligence, because we are building the matrix from the whole data pipeline, from data ingestion, data storage, data transformation, or data warehousing, or data training. So we can collecting this kind of metrics into the same store, and later on we can building more intelligent with models from OpenAI or whatever model you have. You can improve that with data classification and data governance, or the more intelligent on to know when to do the auto compaction, when to do the auto index or auto caching, something like that. So this kind of work is still progressing. Here's just like I said before, a little bit compare with existing modern data catalogs such as Polaris, such as Unique Catalog. So basically, all these three catalogs are Apache v2 license, and on the data lake and the data warehouse support. So we support such as Hive, MySQL, PG, Iceberg, data formats, Python, and Hoodie, which is in progress, and Doris. And also, we're providing the unstructured data support. We're providing the messaging support. And also for engine support, we already support Trino, Spark, Flink, and PyTorch Ray, and we're providing the web UI. This kind of feature and functionality is increasing fastly. And here's a little bit data about each project. So we have a very active community, which is contributed by many company and contributors. So I would like to thanks to the community. I mean, not only us, but also many companies and individuals working in the community, contribute to the community. That make us a project growing faster and make our project to be more and more successful. I would like to thank you, the community, for that. And also, since June, mid of this year, we decided to donate to Apache. So if you look at the Apache journey or the star journey, comparing with the other two Apache projects such as Iceberg or Hoodie, so we are very similar or even faster than growing than them. And all this community the community driven project, the project itself is running very fast. So in this year we have 5 major release and 5 minor release for the year to get planned for 2024. In these days, we just releasing the version 0.6. In version 0.6, it's currently releasing with the RC4. We have a lot of new features such as Python implementation and also centralized access control. And also we have, Iceberg REST catalog support, more elegant support for Iceberg REST catalog. And also we have the Flink GraphTino connector to make the Flink engines running more robust in GraphTino. And also we support the classification such as attack mechanism. In next release, 0.7, that is targeted to be released on October, we'll have a more on unstructured data management, such as we will, instead of support S3 or HDFS, we will support some FuseFS support. That is more useful for when you're managing your unstructured data. And for 0.8, we were providing more AI-related technology features, such as we were providing the manageable capability on your different vector database or vector stores. So please, if you are interested on the GraphTino community, please join us. We believe the open technology, just like I said, the on-silo mission, it will be more and more challenged due to the reason I just mentioned above. So we need an open technology and open community and even the open standard to solving all the problems. And if you want to join the Datastrato and the GraphTino talk on the Slack, so we have some Slack channel there. And also, if you're interested in us, just drop me an email or find me in the LinkedIn. Thank you, everyone.
All right. Now do it again, since it's now me directing it. Quack, 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 quack. All right. I'm here to quack with you on DuckDB architectures for data engineering, data analytics, and data apps. I am a co-founder at a company called Motherduck, which builds a cloud data warehouse based off of DuckDB in close partnership, but with the DuckDB Labs folks, but we are not them and they are not us. You can reach me on Twitter at RyGuyRG. Mostly what I'm here to do is get you to think differently about data infrastructure. I think that there's been a lot of tendency in Silicon Valley for us to like establish patterns and then keep using those patterns even as a bunch of the dependent variables change. And so that's what I'm here to have you think differently about. And the first thing is around scale. The idea with scale here is for a long time, we've equated scale with being distributed. This is probably around the year 2000 up until the present day. If you wanted to handle a lot of data, you had to have a distributed architecture. And I believe this. I worked with Felipe on Google BigQuery, which I'll talk about here in a second. But I totally believed that this was necessary. And frankly, it was necessary back when this rule was formed. So I started my career 22 years ago. Prior to that, I was a student, and my first big student project failed because of big data. My database queries were super slow. It was quite frustrating. But I was in the process of setting up all these brand spanking new Dell servers. As a quick aside here, I've heard ads for Dell recently that don't even give the website URL. They just say call 1-800 something, something, something. And I was like, wait, what has Dell become? But anyway, that's an aside. But I had this solution for my database problems. I could just add more servers. And I did that. Well, it turns out that my queries weren't actually slow because I needed distributed compute. My queries were slow because my brain was slow and did not yet learn about indexes. And had I just applied some beautiful, beautiful indexes, I probably could have used like a tenth of one of those machines. But you come across a problem in computing and you add more hardware and life is good. Then I worked on BigQuery. Infinite Google scale. And
pretty high performance for analytics as long as you learn to think about your data differently. There were no joins at the time. Everyone wanted joins, but instead you had very, very wide tables. What was awesome about it, though, is every query that I would execute would hit 1,100 different machines. And that was pretty cool. Half the results were actually thrown away, so that the performance of one machine wouldn't impact the performance of the query as a whole. And as a computer scientist, this was pretty intoxicating. I could run these queries and you could just envision, 50 racks of computers all crunching away on your queries, which was pretty awesome. But these machines all needed to talk to each other to coordinate the work. And that talking was expensive. But nonetheless, distributed compute was important. I believed that by the year X, you will have tons and tons of data and you will need distributed compute because data is going to grow tremendously huge. Well, I was wrong. I then went on to a company called Neo4j, which is graph databases. And they had this unique architecture of just scaling up. Now, I was there starting in 2013, 2014. And the number one objection with Neo4j was that it didn't scale because it wasn't distributed, which again may have been true at the time for some people. But then I went on to work at Databricks and Spark, and the number one request we always got was, how can I have a single node Spark cluster in my Databricks installation? Which is pretty ironic considering, what Spark is intended for. But people really just didn't need the power of distributed compute. Data hasn't really grown as fast as we predicted. The data that people are analyzing, there's actually a great paper by the Amazon Redshift team, who is going to be presenting at Small Data SF, about the data that people are analyzing on there. We've also just had a lot of experience amongst our team. But most people are not analyzing petabytes of data. Silicon Valley may be different. That's the other thing, is these technologies are built by people in an environment that you might have petabytes of data. How many of you have petabytes of data at work? Okay, well, not you guys, but you used to. So, 99% of people don't have petabytes of data. We saw that 95% of the users of BigQuery had less than 1 terabyte of data. Most enterprise data warehouses are less than 100 gigabytes, according to Gartner. And even most of the B2B SaaS companies funded by Andreessen Horowitz have less than 1 terabyte of data. And this is total data size. But most of your data actually isn't, the data that you're processing isn't the total data size. You're actually processing data that's most recent. You're processing this week's, this month's, this quarter. Everything else is pre-aggregated, computed, reported on. Beyond that, you only touch a few columns, and query technologies have gotten good. So only touching a few columns, even if you have terabytes and terabytes of data, probably means that you're not querying terabytes and terabytes of data. Meanwhile, hardware has massively improved. So when I worked on BigQuery in 2012, largest EC2 instance was 60.5 gigabytes of RAM. Does make me feel kind of old. But today the largest EC2 instance is 25 terabytes of RAM. And who knows, that could have changed since I put this slide together. But that's a 400x difference. So hardware is improving. The data isn't as big as we thought it was. Machines of yesteryear were tiny. Today, the machines are much bigger. But most of our data infrastructure is still built to handle these distributed workloads. Why? Well, one machine today really can handle as much, work as hundreds of machines from 2012. Do we have hundreds amount of data, hundred amount of compute? Maybe in some things, but not in a lot. So the idea of scale being distributed, let's think about it. Let's think if that's really the truth that we want to perpetuate, especially given that one way to think about scale is on the opposite axis of usability. The more distributed scale that we get, the less useful a system is in many cases. It's harder to debug, harder to understand, harder to build and support. So this is kind of DuckDB. DuckDB created at CWI, which is the Dutch National Computer Science Research Institute, by my friends Hannes and Mark there, maintained by DuckDB Labs and the community and foundation. We do work with them very closely. They are shareholders in Motherduck, but they are a separate company. But I want to talk about, a lot of this is about DuckDB core stuff. We'll get into a little bit of what Motherduck is doing, but overall, DuckDB advertises itself as a fast in-process analytical database, which I'm very happy about this newfound messaging. Because at one point it was even more geeky messaging, which kind of scared some folks off. But what does this mean? It's in process, means it runs in your Python, in your R, in your C++ code. It has no external dependencies. They've rewritten pretty much everything to ensure that there's no external dependencies. So, it has its own Parquet parser and writer and things like that. Rather than relying on external libraries. And then it's OLAP, which means that basically it's built for aggregations, built for full SQL support, although there's also APIs that allow you to use it in a more Pythonic way or a more R way, things like that. And, it's really has its own underlying storage engine. A lot of people think DuckDB doesn't actually have storage. They think it's purely in memory. It does actually have a storage format. It's actually kind of an awesome storage format. You can think of it as similar to something like Parquet, but it puts all the tables into one file. So it's really easy and transportable. And you can think of it as the SQLite for analytics. I probably have at least like 20 copies of SQLite running on my laptop, probably another 20 on my phone. SQLite is one of the most widely deployed libraries out there that no one really knows is there. And it really is the transactional database that's kind of a library embedded mechanism, which is analogous to DuckDB as the analytical version. So to talk about architectures, what I will call as the most usable architecture of them all. Anyone want to guess? Yeah. Your laptop, right? Like a single database running on your laptop. Nowadays, my M1, which is ancient, 2.5 years old, 32 gigabytes of RAM, 10 cores, is practically a supercomputer. And you can run DuckDB on your laptop and take advantage of the 90% idle compute when you're not on certain websites or using Google Meet or something like that. Your computer is basically sitting 90% idle. So why not take advantage of that? And DuckDB provides a great way to do that, either as the embedded library or as a command line client, or as you can use dbeaver with DuckDB, all sorts of ways of using it on your laptop. And we'll get into some more, but I want to talk about data apps and SaaS apps and how most of them in a 3-tier architecture work today. Is basically you have your users connecting to a SaaS application. That SaaS application connects to a backend database, the super large database with all the data in for that application. We find a lot of people doing this pattern who then start to try to do analytics on top of those databases, like Postgres database as an example, and they hit a wall at some point where they can't scale anymore without spending a lot of time building indexes, reminding me of college, but without basically putting a lot of work into it. So they want to pull their analytics out into a true analytics database. And powered by DuckDB, there's a unique tenancy model that you can do with DuckDB. DuckDB is a 20 megabyte executable. With a 20 megabyte executable, it's really fast to spin them up and spin them down. And so you can essentially give each of your users their own DuckDB instance for running their analytics. And what this means is you get this great property where users are not colliding with each other. Is one great property. Another great property is that the user's data remains isolated. One of our top customers at Motherduck is a company called FinCore. They do B2B analytics for services businesses, basically anyone with recurring revenue. And all of their data needs to stay separate per customer anyway, or at least they never intentionally are mixing in data between their customers. So this is a great way of allowing them to scale for each of their customers while also staying, keeping the data separate. So that's not all, though. Anyone know what this is? WebAssembly, yes. Have anyone, who knows what WebAssembly is? Okay, handful. So basically, WebAssembly allows you to run binary application code in the browser. So you don't have to write all your code in JavaScript. You can actually have compiled code that runs in the browser, and DuckDB will actually run in the browser. So what does this allow you to do? Some people might say this is a new style of distributed computing. I'm just going to ignore that irony here for just a moment. But if you look at the top here, each user can actually have their own DuckDB instance running in their browser on their local machine. And that DuckDB instance can then talk to the DuckDB instance that's in the cloud. And what that allows you to do is have very low latency between your application and the data. And that low latency allows you to build new types of applications. But this is, this may look complex, but in reality, it's actually quite simple because you're running the exact same database locally in the browser as you're running in the cloud. There's not a translation problem. There's not different, ways of accessing it. It's the exact same database. And this shows you kind of the power of what you can do with that. This is by University of Washington and CMU called Mosaic. And it's showing you data visualization. And if you grab a boundary here, it's doing a SQL query for every adjustment that you're making on that boundary against the local DuckDB database after having loaded the data from DuckDB in the cloud. And you can see how quickly that populates. First of all, it's awesome because you have less JavaScript to write if you're someone like myself. But second of all, it's just really usable. It creates new types of experiences that you can build because of that low latency access to the data. All right, so that's applications. Then someone might ask, hey, well, what about data warehouses or for data teams doing things? This is an architecture that's similar to what we use for our internal data warehouse. Basically, you have data writers writing to a DuckDB database. And then in Motherduck, you have this concept of shares where you're sharing read-only instances of the data. And then each user is still getting their own DuckDB instance, which allows, again, the same sort of resource isolation that you have in the data app use case for your consumers of your data warehouse, and allows you to have a lot of control over when you push updates to your users, which is noticeably interesting for people doing like building machine learning models and things like that, is they can essentially have consistent versions across the team of the data that they're training on. And again, you can also add in that idea of having DuckDB running in the browser. Most notably with this is a lot of the BI tools nowadays that are being built actually use DuckDB under the hood in order to do visualization with that low latency, in addition to obviously then connecting to DuckDB in the cloud. So you might wonder, how do these local DuckDBs work? I say that it's pretty simple. From a user standpoint, it is actually pretty simple. So Motherduck has this thing called dual execution, which basically the general architecture of Motherduck is when you use the DuckDB client and you start to access Motherduck resources, it will just load in a Motherduck extension. So you don't really have to do anything special other than use vanilla DuckDB. But then you can start writing queries that look like this, where you're intermixing data from the cloud with data that is local. So like a CSV file that's on your local machine, as an example. This could be a DuckDB table on your local machine as well. But you can actually intermix that, and the query planner decides which parts of these queries should be processed locally and which parts should be processed in the cloud. And then, of course, you can also just materialize data from the cloud. You can write in your WASM DuckDB, you could just say create table and a local table name as select star from the remote table name. And that also works as one way of pulling data into the DuckDB in the browser. So you might wonder what else this has to do with AI. One thing I would say is I think data and AI are merging. The professions as a whole are kind of merging together. But what does that mean? Well, people are demanding easier access to their tools by all different personas, right? And DuckDB's popularity, apparently this yellow does not really like the projector. The projector does not like this yellow. Basically, you have all sorts of different personas on a data team. Nowadays, DuckDB has gotten to be very popular because it works for all those personas. If you're a Python user, you can use native Python APIs and access the data. If you're a SQL person, you can actually write SQL queries and access the data. If you're trying to do it, over JDBC or ODBC, you can use that, right? So no matter what types of people are using it, whether they're developers or data scientists or data engineers, they all have the same technology that they can use and access in different ways. And of course, you already saw accessing it in different places as well. So whether using it in the browser, using it on the edge, or using it in the cloud. And giving data people access to AI-powered technology. One last thing that I wanted to show here was we just launched this, a week or two ago, ducking easy embeddings. So embedding functions, basically, this actually calls, this isn't being all done within DuckDB or within Motherduck. This actually calls OpenAI currently. But what it does allow you to do is say, hey, I'm going to create a table and set a column which represents the embedding of the text in my table, and then start to do queries here using cosine similarity to find the text that most closely matches that. And it's just really simple, easy to use. Not nearly as powerful as some of the other stuff talked about today or as configurable, but really simple. So time to think differently. That's what we're saying is we really want everyone to kind of make sure that they're understanding what their requirements actually are and not just kind of picking up the technologies because they're highly distributed. And part of that is the Small Data SF, which is a conference we're hosting here in a few weeks, September 23rd and 24th. Workshops on the first day, sessions on the second day. We have some really awesome speakers and co-organizers with the Olama folks in Terso. And what I'm offering you guys here today is 3 tickets for free at random for those of you who write me by midnight tonight. at that email address. I'll be specific, midnight Pacific daylight time. Yeah, daylight time, right? Yeah. And if you write me tonight with the subject of love small data, I will randomly select 3 of you for tickets, and then $100 off for the others there. And then the last opportunity to get free stuff, including money. I'm seeing someone take a picture here, so I'm pausing slightly. But including money is there's a DBT modeling challenge right now. I don't actually have, someone on my team wanted me to put up a QR code or something. I don't actually have a QR code, but if you search this, if not, you have my email address, you can find it. But there's $3,000 of prizes going on with this contest right now. And we'll try to throw in some tickets for the Small Data SF for free too. So that is all I have. So start querying instead of quacking. And the querying can be questions for me, or the querying can be actual querying. Thank you.